According to the law of conservation of mass, mass cannot be created nor destroyed. Therefore, the mass of the reactants must be equal to the mass of the products. In today's lesson, we are going to look at Roman numeral 2D in your notes packet. This is about the law of conservation of mass. You are going to prove the law of conservation of mass for balanced chemical equations. Here's your first chemical equation. Notice that this equation is already balanced. Because there were two oxygens, we put a 2 in front of the calcium oxide, gave 2 calciums, so I'm going to put a 2 in front of the calcium. Before I can show how the law of conservation of mass applies to this equation, I must look up the masses of the individual elements. Recall that the mass of an element is found underneath its symbol on the periodic table. For example, calcium is 40.1 grams. I'm going to round it to the nearest tenth. Oxygen, rounded to the nearest tenth, is 16.0. I'm going to use those masses to find the total mass of 2 calcium oxides, which is the reactant side of my equation. Calcium, 40.1, plus oxygen, 16, gives a total of 56.1. Now, because there's a 2 coefficient in front of it, I'm going to multiply the 56.1 times 2. This gives me 112.2. So the total mass for 2 calcium oxide formula units on my reactant side is 112 grams. Now I'm going to move over to the product side. Calcium is 40.1. There's a coefficient of 2 in front of it. I'm going to multiply 2 times 40.1. So the mass of my 2 calcium atoms is 80.2 grams. I look at the oxygen separately because it is separated by the plus sign. Each oxygen is 16 grams times the 2 subscript is equal to 32 grams for my oxygen. My final answer is when I write it out in the equation form. 112.2 grams of calcium oxide yields 80.2 grams of calcium plus 32 grams of oxygen. Again, to prove the law of conservation of mass, the 112.2 on the reactant side is equal to 80.2 plus 32, the total mass of the products. So I've shown the law of conservation of mass by showing that the mass I start with in my reactants is going to be equal to the total mass that I end with in my products. Here's example 2. First, take a minute to balance the equation and look up the masses of the individual elements. Aluminum has a mass of 27. Chlorine has a mass of 35.5. To balance the equation, you're going to put a 2 in front of aluminum chloride, a 2 in front of aluminum, and a 3 in front of the chlorine. Now it's time to find the mass of 2 aluminum chlorides. So you could find the mass of aluminum and then the mass of 3 chlorines and then multiply by 3. In this case, I decided just to say there are 2 aluminums and there are 6 chlorines. Just like when you're counting to balance your equation, I went ahead and counted 2 aluminums, 6 chlorines. 2 aluminums times 27 is 54. 6 chlorines times 35.5 is 213. I add these together I get 267. That is the mass of 2 formula units of aluminum chloride. Two aluminums have a mass of 27 each, times 2, that gives me 54. Can you finish this? You should have recognized that there were 6 chlorines times 35.5, and that is 213.
Girls and boys interested in track, please meet in the gym doing advisory. Boys and girls interested in track, please meet in the gym doing advisory. Thank you.
Here is our final answer. 267 grams of aluminum chloride yield 54 grams of aluminum plus 213 grams of chlorine.